Some of us just joined. Good evening, students. The class has begun. You can see some questions on the board. Copy a question and work the answer and then take the next one.
Ma'am, for this first question, the answer is 15a plus 9x, ma'am.
Yes, question?
Ma'am, for that first question, the answer is 15a plus 9x, ma'am.
15 plus 9x, ma'am.
Yeah, perfect. 15a plus 9x. Perfect. Yeah, we'll see the answers. Yeah, that's right. In the first answer, since we already have this letter A in the terms in the question, I've used a capital letter A just to differentiate so that we don't get confused with the A's. I'll come again. In question number 1, in the sequence, we find the small letter A. So just for the sake of differentiation, I've used a capital letter. A2 minus A1, I've used capital letters just to differentiate. Otherwise, we use a small letter A. It's a small letter A2 minus A1. Good evening, Shahid. It's sometime we started the class. Get started. You can see some questions on the board. Yeah, take down the first question and work the answer.
Yes, ma'am.
In question number 2, we are given the sum. We are given the sum of the fifth term and the ninth term. The fifth term is A5. The ninth term is A9. The sum of the fifth and the ninth term. So A5 plus A9. Sum meaning addition. Fifth term is A5. Ninth term is A9. The sum of the fifth term and the ninth term of an AP is 72. So A5 plus A9 is 72. Likewise, the sum of the seventh term and the 12th term is 97. The seventh term is A7. The 12th term is A12. Their sum is A7 plus A12, which is given to be 97. So we get two equations in A and B. We need to solve these two equations to find the values of A and B, and hence find the AP.
Ma'am. Ma'am.
Yes, Shahid.
Ma'am, screen is not clear, ma'am. It's blurring, ma'am.
I'll just check with the others also.
Yes, ma'am.
No, but nobody's told me that so far. Just zoom into your screen and see.
Ma'am, no, ma'am. I can't see the screen, ma'am. It's blurring, ma'am.
Ma'am, the screen is fine, ma'am.
It's clear?
Yes, ma'am.
Okay. Who's that?
Miss Varun, ma'am.
Ma'am, this is Anirudh, ma'am. It's clear.
Okay.
Ma'am, for me it's blurring.
Yes, ma'am. The board is not clear, ma'am.
இங்க தெரியல மேம். Shahid, it's still not clear?
No, ma'am. It's not clear, ma'am.
Ma'am, me also fully blurred.
Ma'am, for me also.
Fully
Auntie,
blurred.
for me also,
Can't
auntie.
able to see.
It's not very clear, ma'am, but somewhat blurry.
Yes, it is clear for me, miss.
In question number 3, we need to find the 8 terms on the end. So, to answer this question, we first need to find the number of terms in this AP. We need to find the number of terms in this AP. Now, just assume that these numbers are people standing in the queue. Alright? We just assume that these numbers are people standing in the queue. Now, they are given total numbers from 1
23.
Ma'am, you muted yourself.
Ma'am, you're muted, ma'am, and you're
Yeah, thank you, thank you. So I was telling you, the value of n is 23, which means this sequence of numbers, which is lately has 23 terms. The sequence has 23 terms. Now what's the question? We need to find the 8th term from the end. So are we going to do 23 minus 8? No, we'll understand that. So which is the first term from behind? Which is the first term from behind?
84, ma'am.
Term itself, correct? The first term from behind is the 23rd term itself. Which is the second term from behind? The second term from behind. The 22nd term, correct? The 22nd term. The 22nd term is the second term from behind. So now see what happens. 23 minus 0, which is the last term from the end, the 23rd term itself. So it's like 23 minus 0, which is the second term from behind. You need to do 23 minus 1. Just take 1 less than the term which you have to find from the end. I'm trying to say if you want to find the 8th term from the end, just do 23 minus 7. You're not supposed to do 23 minus 8. If you have to find the 8th term from behind, you simply have to do 23 minus 7. 23 minus 7. What is that? Can somebody tell me?
16.
23 minus 7. Which is the 7th term? Which is the 8th term from the end? Are we all there?
16.
Yes? Are you getting me? The last term or the first term from behind is the 23rd term itself. So you did not do 23 minus 1. The last term from behind. Sorry, the first term from behind. The first term from behind is the 23rd term itself. So which is like 23 minus 0. The second term from behind is the 22nd term, which is 23 minus 21. So if you have to find the 8th term from behind, you just have to do 23 minus 7, which is 16. So A16 is the 8th term from the end. So find A16. So the first step to answer the third question was to find the number of terms in the sequence. How do we find the number of terms? Go up to the last term and find its position. So the last term in the sequence is 84. So you have to go up to 84 and ask the position, its position, which means you will have to work an is equal to 84 to find the position of 84 in the sequence. So an is equal to 84. On working that, we get n is 23. The number of terms in the sequence is 23. We have to find the 8th term from behind. So, which means you simply have to do 23 minus 7, the number of terms, minus 1 less than 8. So, 23 minus 7, which is 16. So, the 16th term is the 8th term from behind. And A16 is 59 and a half.
Ma'am, I finished this question, ma'am.
Yes?
I finished that 5 sums, ma'am.
Yeah. The other questions are coming up. Just 2 minutes. So in question number 4, we need to find which term of the AB, root 2, root 80, root 50 is root of 2450. So we need to find the position position. We need to find the position of the term root of 2450. So this is how we need to present the AB. Root 80 is a pure sum expressed as a mixed sum. So you know this. Write 50 as 25 into 2. It's just a prime factorization. You could find all the factors and also do it. I've written it straight away. This is a perfect square. 1225 is a perfect square into 2 will give you 2450. You could do it on your own style. It's a pure sum. Express a pure sum as a mixed sum. So that's what is it here. And now we need to find the position of this term, which is 35 root 2. So which means AN, some term of the AB is 35 root 2. You need to find its position. Some term of the AB is 35 root 2, which means AN is 35 root 2. AN is A plus N minus 1 into B is 35 root 2. So we have the values of A and B. Substitute. See, this equation basically has three unknowns, A, N and D. This equation has three unknowns, A, N and D. So we know the values of A and B. So of the three unknowns, you know the values of A and B. So work in this equation, you can find the value of N.
Ma'am, in sixth question, where is the AP,
Yes.
ma'am?
Yes.
Ma'am, in sixth question, where is the AP?
Yeah, I haven't written it. Sorry. I missed to write that. Yeah, thank you. Yes.
Ma'am,
Yes.
screen is blurring, ma'am.
No, always tell your name before you talk.
Ma'am, Shahid, ma'am.
Yeah.
Ma'am, from the first screen is blurring, ma'am, from the first itself.
Ma'am, this is Anirudh, ma'am. It's not blurring, ma'am. It's very clear, ma'am.
Okay.
Ma'am,
Is this
I'm
screen blurry
Diksha,
for
ma'am.
anybody else?
Ma'am,
I think it's nobody has told me this so far. Shahid, I think we need to check the internet strength.
yes, ma'am.
Yeah, because if most of us have this issue, then I have to look into it.
Now it is clear, ma'am.
Ma'am,
I'm
your
muted.
screen
Ma'am, you
video
have
itself, ma'am.
muted, ma'am.
Ma'am, audio is
Ma'am, you are
muted.
muted.
Yeah. I should get used to it. Sorry. Yeah, thank you. Yeah, in question number 5, we need to find if 302 is a term of the AP. So you don't, it may be a term, it may not be a term. We need to check if 302
Ma'am, the answer is 101.3, ma'am. 101.3.
Not a term, ma'am. Ma'am, it is not a term of AP.
Yeah, I'm not showing the steps. What's the value of n? What is the value of n? Students, what's the value of n?
101.3, ma'am.
Yeah, so it's 304 by 3, correct?
Yes, ma'am.
Yeah.
Yes, ma'am.
N must be a natural number, any counting number. 1, 2, 3, 4, 5, and so on. It must be a counting number. So here n is not a counting number, it's not a natural number. So 302 is not a term of the AP.
The right part of the board is not visible, ma'am.
Ma'am, it is out of focus, ma'am.
Yeah, just a minute. Is it fine now?
Yes, ma'am.
Yeah. Thank you.
Yes, ma'am, it's clear, ma'am.
Yeah, thank you. So here in question number 6, which term of the AP is the first negative term? So you can see that the terms in the sequence are reducing. We can see the common difference is negative. The common difference is negative. The first term is 20, and then we have 19 and a quarter, then we have 18 and a half. The terms are reducing. So there will be a point when the terms will get negative. Correct? After point, the terms will be negative. You need to find the first negative term. See, just take the sequence 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0, and then from there on it's going to be -2, -4, -6, and so on. So when the common difference is negative, the terms of the AP will reduce, and after a particular point, the terms will be negative. You need to identify the first negative term of this AP. See, the terms are not increasing. It's not 20, 22, 24. The terms are not increasing. If they increase, that is when the common difference is positive. When the terms increase in value, there will be no negative term in the sequence. But you can see here, the first term is 20, then it's 19 and a quarter, 18 and a half. The values are decreasing. So there will be a point where we will get negative in numbers, and from there on, all the numbers in all the terms in the sequence will be negative. So we need to find the first negative term of this sequence. So the condition is, so how do we express negative values? Values less than 0 are negative. Values less than 0 are negative. So the condition is which term, so which means an, which term is less than 0? Which is that term which is less than 0? Which is expressed like this. An, we need to work with the condition an less than 0. Why less than 0? Because you have to find the first negative term. Negative values less than 0. So we need to, this is the condition we need to work with. An less than 0. An is a plus n minus 1 into b. We know the values of a and b. The three unknowns are a, n, and b. Put the values of a and b and work this to find the value of n. But since you're working with an inequality, we need to be careful. So see here, after filling the values, we'll see how to simplify. 20 multiply, see this is n minus 1 into t. It's not n minus 1 minus 3 by 4. It is n minus 1 into t. This is multiplied by t. So it's n minus 1 into minus 3 by 4. You need to multiply the terms of this bracket by 3 or minus 3 by 4. Correct? It's n minus 1 into multiplied by minus 3 by 4. So how do you got this? 20 n into minus 3 by 4 is minus 3 by 4 n or minus 3n by 4. Multiply n with this and minus 1 with this. So minus 3 by 4 into n. Minus 3 by 4 n. Minus into minus plus. 3 by 4 into 1 is 3 by 4. Less than 0. Now simplify these two. This is an n term. Simplify these two. 20 plus 3 by 4. Take a LCM and simplify. So 83 by 4 minus 3n by 4 is less than 0. Now transpose, we need to find the value of n. So transpose. So we have minus 3n by 4 less So here we have minus 3n by 4 is less than minus 83 by 4. So you're taking out the minus sign on both the sides. See here we are moving the minus sign on both the sides. So what happens? The inequality is reversed. The inequality is reversed. So this less than becomes greater than the next one. That's it. So then you just have to simplify the usual way. 3 by 4 on the other side becomes 4 by 3. And we have n greater than 83 by 3 or n is greater than 27 2 by 3. N is greater than 27 2 by 3. N is greater than 83 by 3, which means n is greater than 27 2 by 3. So now answer the question. Which is the first negative term? N is greater than 27 2 by 3. Which means the 28th term, n should be greater than 27 2 by 3. Which means the 28th term is the first negative term of the sequence, and from there on, all the terms in the sequence will be negative. The first negative term is the 28th term, and from there on, all the terms of the AP will be negative. Now children, go ahead work out this and go ahead.
I'm finished, ma'am.
Ma'am, your screen is not visible, ma'am.
Yeah, yes, children. Oh, is it going?
Your screen is not visible, ma'am.
Yeah. Is it fine?
Yes, ma'am.
Yeah. In question number 7, we have the first term of AP, A is 7, and it is 125. Tell me the last term of this AP is 125, which is also AN. AN, some term of the AP. N is the last term, so you can also call it AN. AN is 125. And what's the value of N? 60. This AP has 60 terms. N is 60, meaning the AP, this AP has 16 terms. The finite AP. N is equal to 60. So this AP has 60 terms, in which the last term is 125. So if the last term is 125, it means the 60th term, A 60, is 125, correct? Here, A is 7, N is 60, N is 60. So this AP has 60 terms. And when N is 60, we have N is 125. The last term is 125, which means the 60th term is 125. N is the 60th term because N is 60. The sequence has 60 terms. So N here is the last term. What was 60th term? So N is equal to 125, means the 60th term is 125. So you can easily work this. A60 is 125, which means A plus 59D is 125. So we have two unknowns, A and B, but we know the value of A is 7. Work this and find the value of D. Yes, Harnishri, what's the value of D? Okay, and the 32nd term, Harnishri, what is A32? Harnishri, what is A32? 69, correct. Yeah, correct, thank you. How do we got this? How do we find A32? A plus 31B. So A is 7 plus 31 into 2.
ఎట్లా అక్సెప్ట్ చేస్తారు చేయరా అంతోడు చేస్తారా
Children, no conversation between yourself. All of you put your mic on mute.
Ma'am, the video is blank, ma'am.
So in question number 8, we have an arithmetic series. That is, we have the sum of the terms of this arithmetic progression equals 660. See here, 5.5 plus 11. The terms are not separated by a comma. The terms are connected by a plus sign. So this is called an arithmetic series. When the terms are connected by the plus sign, it's called an arithmetic series. Alright, so this series totals to 660. 5.5 plus 11 plus 16.5 plus 22. So on up to how many terms we do not know. We do not know this last term an, which is written as x here. The last term is an. The last term in the sum here is an, and that is written as x here. So don't worry about that. What you have here is the sum of, we don't know how many terms. The sum of some number of terms of this AP is 660. So which means A1 plus A2 plus A3 plus A4 plus, we do not know how many terms. So on up to AN. AN is called X here. Alright, so this means A1 plus A2 plus A3, so on up to AN. The sum up to AN is equal to 660. You must understand that. So that's what I've written here. See, this is the default things which you have to write. The first one, A is 5.5. Find the common difference, which is also 5.5. So 11 by 2, 11 by 2. So how do you understand this? A1 plus A2 plus A3 plus A4, like this till AN. The sum to n terms is 660. I'm not helping you to solve this equation. You must know to do it. All that I can tell you is you will get a quadratic equation in n. You will get a quadratic equation in n, and I'm going to just write that equation. I'm not going to show the steps. You need to learn how to simplify this.
Is n is equal to 15 or minus 16, ma'am?
Yeah, perfect. Yeah.
Okay, ma'am.
No, children, once you're done, kindly wait for the others.
Ma'am, n is equal to 15.
Yeah, that's right. Children, no, please put your mic on mute. I'll ask you. We'll just wait for the others.
I have a doubt.
If you have a doubt, speak out.
Ma'am, I am Krishna, ma'am.
Yeah, Krishna.
Ninth question is 67 or 6, ma'am.
Oh, that's a question mark. It's not 67, it's 6. It's 6. It's a question,
67, ma'am.
it's a question, right? How many 3-digit numbers are divisible by 6?
Yes, ma'am. Thank you, ma'am.
Yeah.
Ma'am, board is not visible, ma'am.
So I've solved it for you. I told you I will not, but I've done it. So you can see the quadratic equation. I'll just tell you how I simplified. So out here I take out 11 by 2 common. 11 by 2 is common. Bring it out. N by 2. 11 by 2 is common. Bring it out. So we need to write 1 here because 11 by 2 into 1 is 11 by 2. Take out 11 by 2 common. So in the bracket you have 1. 1 into 11 by 2 is 11 by 2 plus 11 by 2 into n is 11 by 2. Okay, so take out 11 by 2 common. And then we have 11 by 4 here, right? 11 by 4. So on the other side, it goes as 4 by 11. We have 11 by 4 here. 11 by 4. On the other side, 4 by 11. Simplify, this works to 240. And here you have n squared. N into 1 is n. N into n is n squared. So this is the quadratic equation. N is minus 16 or n is 15. N cannot be negative. The number of terms in a sequence What is the count? What is the count of the 3-digit numbers that are divisible by 6? How many is the question? We don't have to find the sum. Alright, so the question is how many 3-digit numbers are divisible by 6? So we need to first generate the sequence of all the 3-digit numbers that are divisible by 6, correct? We don't have the progression, the arithmetic progression, or we don't see any sequence of numbers in the question. We don't see any sequence in the question. So you have to generate that sequence, which is going to be ready. Sequence meaning a set of numbers that have some pattern. So you need to generate the arithmetic progression in this case. Alright, so and the numbers will be all the 3-digit numbers that are divisible by 6. So how do you generate the arithmetic progression, or how do you find the sequence of all the 3-digit numbers that are divisible by 6? This is how it is. So this is the smallest 3-digit number. This is the smallest 3-digit number. This is the biggest 3-digit number. Divide them by 6. Divide by 6. See here, the remainder is 4. 6 minus 4 is 2. Add 2 to 100. 100 plus 2, 102. 102 is the first 3-digit number that is divisible by 6. I'll come again. 100, divide 100 by 6. Divide 100 by 6. The remainder is 4. 6 minus 4 is 2. Add that to 100. 100 plus 2. See here, 6 minus 4. 6 minus 4 is 2. 100 plus 2. 102 is the first 3-digit number that is divisible by 6. So we got the first one. It's easy to find the others. So if the first one is 106, the next number should be a multiple of 6. It should be divisible by 6. So it's going to be 102 plus 6, 108. 108 plus 6, 114. It goes on like that. But what is that last 3-digit number that's divisible by 6? Do that. So see here, perform the long division. The remainder is 3. Simply subtract the remainder. Simply subtract the remainder. I've shown the steps here. 3 is the remainder. 999 minus 3. 996. Now this is the last 3-digit number that is divisible by 6. See there? This is the last 3-digit number that's divisible by 6. So this is the sequence of numbers, or this is the sequence of all 3-digit numbers that are divisible by 6. So we need to first generate the sequence like this. Now to answer the question becomes very easy. How many is the question? How many? Go up to the last number. Go up to 996 and ask 996 its position. Correct? 102 takes the first position. 108 takes the second position.
Ma'am, we cannot see the
Yes?
Ma'am, screen is not visible, ma'am.
Yeah. Okay, children, is it okay now?
Yes, ma'am. Yes, ma'am, it's okay, ma'am.
Yes, ma'am.
So when I start, I was telling you,
Yes, ma'am.
when you go up to 102, then ask its position, it's funny, it takes the first position. So A1 is the first term, 102 is the first term, 180, sorry, 102 is the first term, 108 is the second term, 114 is the third term. So you have to go up to 996. You will have to reach out to 996 and ask
150, ma'am. 150. 150, ma'am.
Yeah, it is 150, which means there are 150 three-digit numbers that are divisible by 6. So children, using the same idea which we used in question number 9, you must be able to generate the sequence in question number 10. See, I told you how to find the first term and the last term in question number 9. The first term of the sequence in question number 9 is 102. We learned how to find it. And the last term of the sequence in question number 9 is 996. We used a particular procedure to find those numbers. Use the same procedure in question number 10. I'll just tell you how the answer goes. The question is to find the sum of all the three-digit non-multiples of 17. So the first thing you'll have to do is to find the sum of all the numbers, all the three-digit numbers, natural numbers, all the three-digit natural numbers, meaning numbers starting from 100 to 999. That's step 1. Step 1 is to find the sum of all the three-digit natural numbers, meaning 100, 101, 102, 103, so on up to 999. Find the sum. That's the first thing. So the first sequence we have is 100, 101, 102, so on up to 999. Find the sum of the terms in the sequence. So that will give you the sum of all the three-digit natural numbers. Do that first. Do that first, all of you. Write out the sequence 100, 101.
Ma'am, for that the answer is 4,94,550, ma'am.
Yeah, come again. I was away. Yeah, tell me.
Okay, ma'am. 4,94,550, ma'am.
Yeah, 1 second, 1 second. Yeah, the answer is 4,94,550.
Ma'am.
Yeah. See, what you see on the board is 100 plus 101 plus 102, so on up to 999. You cannot find the sum when you do not know the number of terms involved in the sequence. That's the first step you'll have to do. So the first step, you cannot directly find the sum. You need to know when you have to find the sum to how many terms is the first question. Sum to how many terms? How many terms are there in that sequence? So again, you have to go up to 999 and ask 999 its position. Where does it stand? In which position does the number 999 stand? Alright, so that's what you should have done first. AN is equal to 999. A term of the AP is 999. So AN is 999. Which means A plus N minus 1 into D is 999. Work this and find the value of N. You must get N is 900. N is 900. Then you'll have to find S 900.
Miss, I am not able to see the screen.
Yeah, we'll finish this answer and wind up today's session, children. Just give me 3 more minutes. We'll just finish it in less than 5 minutes. We'll finish the session today.
Ma'am.
So what we have now found is the sum of all 3-digit numbers that are, oh sorry, the board is behind me. I'm not seeing the board. That's the problem. Okay, the board is behind me, so please excuse. So what you see on the board is the sum of all the 3-digit numbers, correct? The sum of all the 3-digit numbers from 100 to 999. What was the first step? To find the value of n. You cannot find the sum without knowing the value of n. Sum of how many terms? So first find n. How do you find the value of n? Go up to the last term. Who is the last term? 999. Go up to that number and ask that number its position. Which means we need to work the condition an is equal to 999. So there we have the 3 unknowns A, N and D. You know the values of A and D, fill it and find the value of N. So that way we know there are 900 terms. So now find S 900. And I hope you know this formula. Sn is equal to n by 2 of the first term plus the last term. You can also use this when you know the last term. You can always use n by 2 of 2a plus n minus 1 into d here. You can do the same thing here. N by 2 of 2a plus n minus 1 into d also is going to work. But when you know the last term of the sequence, when you know the value of the last term, you can use this formula. N by 2 of the first term plus the last term. So the first term is 100, the last term is 999. So since you know the last term, we'll use the formula n by 2 of the first term plus the last term. And that gives you 4,94,500. Now next what? We need to find the sum of all the multiples of 17. All the 3-digit multiples of 17. We need to find the sum of all the 3-digit multiples of 17. Now the difference between these two answers will be the sum of all the 3-digit non-multiples of 17. So what are the steps? First is to find the sum of all the 3-digit numbers. All the 3-digit numbers. Next step, find the sum of all the 3-digit multiples of 17. All the 3-digit multiples of 17. The difference between these two sums will be the sum of all the 3-digit non-multiples of 17. Let's do that. So like we did in question number 9, this is how we generate the sequence of all 3-digit multiples of 17. So take up the first and the last 3-digit numbers, 100 and 999. Divide them by 17 and use the same procedure we did earlier. So 102 is the first 3-digit multiple of 17. 986 is the last 3-digit multiple of 17. So when you know 102 is the first 3-digit multiple of 17, just add 17 to that to get the next number. But again, you can add 17 to the previous number to get the next number. So like that, we have the sequence 102, 190, so on up to 986. Now what should you do next? We need to find the sum of the sequence, the sum of the numbers in the sequence, correct? We need to find 102 plus 190 sequence. So to find the sum, what's the first step? We need to find the value of n. So go up to 986. Go up to 986 and find the value of n. What's the value of n, children?
53, ma'am.
Sorry? 50?
53.
53.
53.
No, I'll get it from somebody else. Yeah, I'm not. Let me hear from Krishna. Krishna, have you worked it?
Yes, ma'am. 53, ma'am.
53? Okay. Next,
ma'am.
what, Krishna? After finding the value of n, what next?
We have to find the sum.
Ma'am, 28,832, ma'am.
No, please
Yes, ma'am.
wait.
28,832.
Okay, so we need to next find S53, the sum of the 53 terms in the sequence. All right.
Yes, ma'am.
Ma'am, your screen is not visible, ma'am.
Oh. So you see the final answer there? 4,65,718. So in this question we've learned two things. You've also learned how to find the sum of all 3-digit multiples of 17. You've also learned that. How do we find the sum of all 3-digit multiples of 17? You've learned how to generate the arithmetic progression using 100 and 999. The first 3-digit number and the last 3-digit number, or the smallest and the biggest, whatever you call it. The first 3-digit number 100, the last 3-digit number which was 999. Using these numbers, we find the sequence. And after generating the sequence, you have to go up to the last term. Using the last term, you need to find the number of terms in the sequence. That's very important. Go up to the last number and find the number of terms in the sequence. After that, you'll have to find the sum of all the terms in the sequence. So you've learned how to find the sum of all the 3-digit multiples of 17. And prior to that, what did we do? We found the sum of all 3-digit numbers. We found the sum of all the 3-digit numbers. So the sum of all the 3-digit numbers minus the sum of the 3-digit multiples of 17 will give you the sum of all the 3-digit non-multiples of 17. I hope all of us get that. So this session will be followed by a homework. I'll give you some time, similar questions for homework. All the details will be posted in the group. We have crossed the time, it's 10 minutes late. We need to wind up the session today. So it was really interesting. I hope the board was clear all through. I'll just fix that problem. The board was going on and off. So I'll just fix that. Otherwise, I think the session today was very clean. We didn't have any other issue. All right, children, if you have any questions, you can stay back. Otherwise, we are done for the session today. Good night. Thanks and good night.
Thank you, ma'am.
Yeah. Children,
Thank you, ma'am.
if you don't have a question, you can stay back.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Very sleepy. I'm not leaving the meeting. I can see two of you. If you're writing from the board, I'll wait for you. I can see Srivatsan still in the meeting. Srivatsan, are you writing from the board? Srivatsan?
Completed, ma'am. Thank you.
All right, ma. All right. Yeah. Thank you. Good night. Vishwavardhini, I'm waiting for you. I assume you're writing something from the board. Vishwavardhini,